KPBS On Demand is supported by Paint Care, offering households and businesses in California more than 800 leftover paint drop-off sites for recycling. Quantities of 100-plus gallons of paint may qualify for a large volume pickup. Learn more at paintcare.org.
I'm Beth Accomando, your resident cinema junkie. Today from the archives, I'm pulling out my interview with theNAT's curator of entomology, Dr. Michael Wall. He'll be introducing the new giant bug movie, Stung, tonight at 9 p.m. at the Digital Gym Cinema. So if you're wondering if he's worth coming out to hear, or if you can't make the show, this interview will give you a taste of how much fun entomology can be, and how scary the insect world really is. I begin my interview with a behind-the-scenes tour of theNAT's entomology department, where Dr. Michael Wall let a scorpion get away from him and run around on the floor. When my videographer Katie Shulov asked if it was dangerous, Michael laughed and said, "No, it's not lethal. You won't die from it. Oh yeah, it would hurt if you got stung." I wish I had video of that, but I don't, sorry. So let's just start our tour behind the scenes at theNAT's entomology department with Dr. Michael Wall.
We're going to take a little behind-the-scenes tour into the entomology department. This is our entomology work lab where we got lots of microscopes and lots of vials of various types of insects that we've collected on different projects. This is mostly spiders from Baja, California. And over here we've got some of our living critters that we use mostly for educational purposes. So this is one of our native tarantulas. There's about 2 to 3 species of tarantulas that are native to San Diego County. There's also a scorpion hiding out back here. There's about a dozen different species of scorpions in San Diego County, so a lot more diversity than people think. And in fact, Baja California is the most diverse place in the world for scorpions.
Most people think of a museum as a place you go to see things on display, mostly not living things.
Right.
So tell us a little bit of what theNAT does kind of behind the scenes in terms of studying bugs or contributing to science.
The insect collection has, we've got around 600,000 specimens in our insect collection. About 75% of those are from our region, so we really do focus on our region. So a lot of that's behind the scenes, and so how does it used? What's the point of having all these specimens back here? Not only are they used for research, like kind of your traditional university professor research type things where they'll actually come and borrow material for us. So in a way, our collections are kind of like a loan library for that type of research. But one of the benefit that we've created for the community, I guess, by focusing on our region, is that we know a whole lot about life in San Diego County because of the collections in the Natural History Museum. And we know about that life stretching back for over 100 years. And because of that, we can provide data to land managers. The Multiple Species Conservation Plan, which San Diego County is really famous for, used a lot of our data to help protect and manage the wildlands of our county and our region. So there's this combination of this really pure science type stuff, like describing new species and figuring out how they're related to one another. And then there's this very conservation science oriented work that our collections are based off of that help protect our habitats, local habitats.
And so we can see some of these bugs in your collection?
Absolutely, and we can talk more about why we collect so many. It's a common question we get.
So where are we going now?
This is our collection. So this is where those 600,000 specimens that I said we have are housed. And if we walk on back, so each one of these cases is filled with tons and tons and tons of insects. In this case, we're in the section on bees. Each one of these drawers is filled with these unit trays, and every unit tray contains a different species of insect. And it is a pretty common question for us to get is, why do you collect so many? Why do you need this many? Isn't one enough? The answer that I typically give folks about that is that, you know, if you were an alien who was making a natural history collection of the Earth and you came, would you just pick one human out to represent all of the diversity that we have on this planet in terms of humans? If you picked me out, then You would have white guy with brown hair and greenish eyes, about 6'5", and I certainly, without a doubt, do not represent the diversity that is within the human species. The same thing happens here, is that there's all this morphological diversity. We can see differences in shapes and sizes and stuff, particularly when we look at them underneath a microscope. But then also all of these labels have data on them, and that data is about where they were collected and when they were collected. And by taking that information, then we can actually kind of travel back in time, and we can look at what did San Diego County look like, say, before the World War II, when the population boom in San Diego County really took off. And we can compare that to how San Diego County looks now. So we can actually look at the impacts of the changes, human-caused changes or other changes that have happened in our ecosystems. So in addition to the research collections that we also have education material that we take out and use in the community. And this one's probably one of our more popular ones with the public. And so this is called the Sting Pain Index, and there was a researcher over in New Mexico who actually allowed himself to be stung by a whole bunch of bees, wasps, and ants from North America. And he ranked them on this scale of 1 to 4 that you see here. And so down at the bottom you have things like solitary bees, so they don't live in hives. And it says light, ephemeral, almost fruity, sharp, sudden, and mildly alarming. So that kind of, I think all these sound like wines. This one sounds a little bit like a Zinfandel down here. And then you move up to a honeybee, which most people are familiar with. So there you got a little bit of familiarity. And it's rich, hearty, slightly crunchy, hot and smoky, almost irreverent. And then you keep trekking up until you finally get to the tarantula hawk, which is the most painful sting in North America. Pure, intense, brilliant pain, blinding, fierce, and shockingly electric. And so I think he probably was drinking a little bit of wine as he was allowing himself to be stung to create this index.
So where are we going now?
So this is a case filled with various types of arachnids. And so insects have 3 pairs of legs, so 6 legs in total. Arachnids, and actually there's some other things in here in addition to arachnids that are called the myriapods, or the centipedes and the millipedes, and they have more than 3 pairs of legs. So we've got a number of spiders, including tarantulas in here, as well as scorpions. There's a little bit of a rule of thumb with scorpions, is that the bigger the claws, the less the sting. Because think about it as an investment in getting food, because that's the reason why they've got a sting and claws. It's all about food. Now they use it in self-defense as well. So it is a rule of thumb. It doesn't necessarily always apply. I don't encourage people to go out and go, well, that's got big claws, I can handle that, because you will get stung and it will hurt. It just won't be, deadly.
Regarding tarantulas, they get used in films quite a bit. There was Tarantula, where it was a giant tarantula.
Even science was stunned. The new atomic miracle should have been mankind's greatest boon. Instead, when such power to cause phenomenal growth proved dangerously unstable, man was confronted with his most shocking blunder.
The isotope triggered our nutrient into a nightmare.
A blunder that transformed a tiny insect into the 100-foot spider that was now ravaging the panic-stricken countryside.
Are tarantulas really something that people should be scared of?
No, particularly our local species, but tarantulas in general. I think the fear stems from their size. They're just really big, they're hairy, they move really slow and creepily kind of thing. All spiders are venomous, so if you got bit by one, it would hurt. But they're rarely deadly, and our local species are not at all. And probably the most irritating thing about them is that those hairs that they have on their abdomens, they can actually make those come off on you, and it's like fiberglass, so it's really itchy. It didn't evolve because humans harassed them. It evolved because, they probably had skunks and different types of carnivores trying to eat them. And you can imagine if you got a little blast of fiberglass up into your nose, then that would be a big deterrent. And so again, they use this as a defense. It's not necessarily meant to subdue prey, which is really what their fangs are about, is subduing prey.
So what got you interested in bugs?
My bachelor's and my master's degree are actually in botany, and my wife was working on her undergraduate, she wasn't my wife at the time, in entomology. And so she kind of got me a little bit interested in bugs just because I would go up and study with her at the lab when she was studying. But then I started really getting interested in plant-animal interactions, so the way that insects and plants would interact with one another. So pollination is a really common example of that. Also herbivory, insects eating plants. And so once I finished my master's degree, I figured, well, I've got the plant side down. I think I'm going to go for the insect side now. So I wasn't one of those kids who grew up with a butterfly net, though I totally grew up in the woods tromping around, but I didn't grow up, as an entomologist. I mean, one of the things that really got me into entomology is there are these things called Berlese samples, and I can show you guys the stuff that we do it with, but you essentially take leaf litter and you put it into a funnel that has a screen on it, and you put a light up above it, and the heat starts to dry out the leaf litter, so you've collected it from underneath a tree or a bush or something like that. And it starts to dry out, and all the insects go, it's getting dry up there, we want to go down. Well, they go down, eventually they drop into the funnel, and you have a container you can collect them in underneath. And when my wife was taking entomology and I was still in botany, I looked at one of these samples that her class had collected, and it looked like, when you just looked at it with your eyes, there was just a bunch of sand down there. You might have been able to see a little worm here or a tiny beetle there. But then when you actually looked at it underneath the microscope, the diversity, all that stuff that I thought was sand were little mites, or these things called springtails, or they were tiny, tiny beetles. And when you just start looking at things in a microscope and you realize these things are incredibly complex. I mean, that's what got me really into entomology, is that there's this whole other world that's out there, and we kind of don't pay attention to it because it's really, really small, but it does drive all these things that are so important to us, and also it's just fascinating. It's just intrinsically fascinating.
And what was it about the kind of interaction between bugs and plants that caught your interest and made you decide that you wanted to explore further what bugs were doing?
Interactions in nature have always been fascinating to me. I mean, how two different species, either interact in a positive way, or it can be in a negative way, or in some cases it's positive for one, but it's inconsequential to the other. And I took a class in what's called chemical ecology, which is about how chemicals can be the interaction between those two different species. And I think that's what really kind of grabbed me by the horns, because there's all these incredible, crazy interactions that go on between two different species of insects, between insects and plants, that are all mediated by these chemicals, these either pheromones or allomones. And I think it's fascinating to see how the world works.
When you were a kid, did you ever read these science fiction stories or watch movies like Tarantula or?
Oh yeah, definitely. No, I'm a big fan of bad science fiction movies. So them, and it seems like there's a ton about ants coming in and taking over places, but them is probably the classic giant ant story.
We may be witnesses to a biblical prophecy come true, and there shall be destruction and darkness come up in creation, and the beast shall reign over the earth.
Yes, the earth, the skies above and the seas below, infested by swarms of nightmare creatures, crueler, deadlier than the armored giants of prehistoric eras. Here is a wild, headlong flight into terror, as the desert erupts with a grim battle for survival.
There is something, I think, innate that makes people somewhat fearful of insects, and I understand that. But I also find those things really entertaining.
A lot of people do have fears and phobias about bugs.
Right.
Why should we be concerned with bugs, and be concerned if, some of them are becoming extinct
Right.
or are endangered in some
Yeah.
way? So what's important about them? What are they contributing?
One thing is that insects make food taste good, and not because they taste good, but because when they're eating plants, the plants don't necessarily want to be eaten, and so over time, plants have evolved these chemical defenses. Well, those chemical defenses make it taste good to you and me. The flavor that basil has to it, the flavor that lemongrass has to it. Thai food would be horribly bland if insects hadn't, over evolutionary time, selected for these chemical defenses that we find taste so good. Also, insects pollinate. And so between the pollination, the fact that they make life taste good, in my opinion, they're also really involved in nutrient cycling. They're key components of the ecosystem. They're food for lots of other creatures that we like and enjoy. So life without insects, I'm not sure how it would exist, to be honest with you. They're crucial.
I have to confess, I'm a big fan of zombies.
Yep.
And there have been a number of times in the insect world
Yep.
where you see this sense of like zombifying
Yep.
another,
Yep.
one bug zombifying another
Yep.
bug.
Yeah, yeah. And parasites have a tendency to do this. They will eventually take over, the brains. I don't know if it's the brains, but they'll take over their behavior and cause them to do things that they normally wouldn't do. And another great example of that is there are some fungus, so some related to mushrooms, right? The spores get on the insect. Eventually, they start to creep inside of the insect. Again, changing the chemistry of this insect, causing it to alter its behavior to climb up really high. So they'll do it with ants. And it might be an ant that normally forages around on the ground, or at least wouldn't go to the tip top of a plant where it would be easy prey for an aerial predator of some kind. They'll cause them to climb up really high and then just stand there until the fungus takes over their entire body and blooms with these like fingers of fungus that come off. And why do they need to be up high? Well, now the wind blows those spores away so that it can infect the next potential zombie, kind of thing. So yeah, there's tons of stories like that are crazy.
All right, I'm waiting for the next zombie film to like have some bug component. to it.
Yeah. Or a fungus, that is the agent of infection. I mean, some of the most fascinating stories to me are the stories of parasites, because the level of interaction or the specificity of the interaction can just be incredible. And one that I heard very recently has to do with a wasp that parasitizes these cockroaches. What it does is it finds a cockroach, it quickly stings it twice in the brain. It's the very specific places, and when it does that, the cockroach loses its free will. So it can still move, it's not paralyzed, it can still move, but it just stands there. Then the wasp will leave it, go off and find a burrow. Meanwhile, the cockroach is just sitting there, hanging out, waiting for the wasp to come back, essentially. The wasp will come back, actually bite it by its antenna, lead it back to the burrow, where it will then lay an egg on the outside of it, and the cockroach just stays there. It can move. I mean, it can walk. It's like the wasp is taking the thing on a walk. It's just blows my mind that when we do surgery on humans and insert things, if we've got to be so incredibly careful, and these wasps can just quickly go beep beep and sting this thing in the two exact places that causes it to lose its free will. It's amazing to me.
You mentioned that this wasp and cockroach combination was something you learned recently. So do you find that there's still so much out there to learn?
Oh yeah, totally. There's so much. I mean, insects are so poorly known. There's a little over 1 million species of described insects, and the estimates range up to like 10 million more. A lot of people. There was a study published fairly recently that thinks that the number's probably around 4 million. But either way, I mean, just in terms of knowing what's out there, there's so much that we have left to discover. And that doesn't even begin to get into the interactions and how those things interact with one another. And it can be really important to understand those things, because when you have the Argentine ants coming into Southern California and really impacting like not just other insects, but vertebrates as well, like the coast horned lizard, we can use what we know about the ecology of those ants to help control them here, right? And so the more, we know about these things, the better we can kind of make life on the planet, not just, for ourselves, but for the insects as well.
In your studies, when you come across stories like this, I mean, has it ever occurred to you to want to write something like a science fiction story?
Definitely, yeah, because I do. We have a pretty active Facebook page that we're constantly posting the things that we discover, on the web and in the literature and stuff like that. And there are so many cool stories, and I do like to write, so it's somewhere back there on my to-do list.
Well, and it's amazing, too. You see some of these photographs of insects, and some of them I mean, it's a big range from spectacularly beautiful to almost terrifying when you see some of them.
Yeah. No, the one of the insects that will be in our wall, well, it's not an insect, it's actually related to a spider. They're called sun scorpions. That's going to be in our wall of wonder. When you look at the jaws up close on those guys, they're horrifying. I mean, they look. I always refer to them as the lions of the insect world kind of thing, because I mean, they cruise around. They don't have venom, even though they're related to scorpions and spiders. They don't have venom. It's all just about raw power and tearing things apart, and that's what they do. They're brutal.
Did you, when you were growing up, did you ever keep pet bugs?
We kept pet everything that I lived in a neighborhood that had lots of woods around it and stuff like that, and so we would go down to the stream and get crawdads and box turtles and insects and anything that you could try to keep inside of a box. We would try to keep inside of a box for a little while at least. Definitely a kid who wandered around a lot.
Do you encourage that in kids? Do you think that's something that's beneficial?
Without a doubt, I think it's great for kids to be getting out into nature and having an opportunity to explore and discover for themselves. So any way that you can get your kids exposed to more nature, I think is a positive thing for their growth.
I'm Beth Accomando, your resident cinema junkie, and you've been listening to my interview with the NAT's curator of entomology, Dr. Michael Wall. I also spoke with him when The Last of Us video game came out. The designers of that game were inspired by the David Attenborough documentary, where he explained what the cordyceps virus was. This led them to imagining what would happen if the virus jumped from bugs to human beings. The result was a terrifying strain of a zombie-like creature. Here's a clip from the Attenborough documentary, followed by my interview with Dr. Wall.
These bullet ants are showing some worrying symptoms. Spores from a parasitic fungus called cordyceps have infiltrated their bodies and their minds. Its infected brain directs this ant upwards. Then, utterly disorientated, it grips a stem with its mandibles. Those afflicted that are discovered by the workers are quickly taken away and dumped far away from the colony. It seems extreme, but this is the reason why. Like something out of science fiction, the fruiting body of the cordyceps erupts from the ant's head.
The insect world, I think, very often inspires science fiction writers and movie makers, and clearly, in this case, video game producers.
You also looked at the trailer that kind of showed some of these infected people in the game. So what are you seeing kind of in those designs that is tapping into the real world of what happens to these ants?
They're definitely getting at this, the alteration of behavior. Right? Because it's not just like the weird fleshy growths or fungal growths that are coming off of their head and stuff, but they talk in the trailer about the changes in behavior. It's not just like all of a sudden these are normal folks who just happen to have really weird fungal growths coming out of their body. I mean, they're lurking around. They're talking about them now using echolocation to find other people, and so they're definitely tapping into this idea that parasites can change the behavior of their hosts and make their hosts do things to the benefit of the parasite.
Does this make sense to you to find inspiration there? I mean, what kind of things in the insect world are they tapping into? Is there a particular kind of fear or a particular kind of notion that you think makes it particularly good for these things?
The insect world and the natural world in general, but particularly the insect world, really, it allows for us to tap into something that seems out of this world or not of this world, or supernatural in a way, but it's really based in this world. And so if you're having trouble coming up with an idea for something to do, then bury yourself in a few interesting insect behavior books, and you're often going to find these incredible things that don't seem, as you said, that seem like science fiction, that don't seem like they could honestly be true.
One of the game designers talks about that they were inspired by seeing what happens to these insects, and then they make this jump of saying like, oh, what if it jumped to humans? So
right.
What are our chances of something like jumping from the insect world to human?
Jumping from the insect world to human world is highly unlikely. There's, I think, several thousands of these species of fungus that infect a variety of different types of insects, and some individual species can occur on lots of different insects. So you might think like, oh wow, then why couldn't it jump over to us? But in terms of the evolutionary family tree, humans and insects are really far apart.
And do you get enjoyment seeing like the insect world being used in this way? Do you feel like maybe this will somehow get more information out there, pique some kids' interest in the insect world?
I think for me, what is cool about the use of insect-like behaviors in science fiction is that it does give me, as an educator, a point in which to grab onto people because they're familiar with it. So I can start talking about something and say, it's like in Aliens, and people will go, oh yeah. And so because it's popular media, right, more people are familiar with it than the stories that I might be trying to educate them about in terms of entomology. So you can hang your hat on that popular media piece and then say, hey, this isn't science fiction, this is real life,
If you could suggest something to gamers or to Hollywood or something, is there a particular thing, behavior or incident in the bug world that you think is really cool or interesting that might be a leaping point for some idea?
There's a whole bunch. But one that I think about very often, because I'm very interested in specialization, so how insects can occupy these really incredibly small niches in the ecosystems. And there are groups of flies where the adults will only feed on like the hemolymph the insect blood of another insect, but only after it's been killed by another insect. So they require something to be killed, and you'll see there's these insects called assassin bugs, and you'll see them they've got beaks poked into another insect. They're sucking the juices out of it, and there'll be all these little tiny flies on the outside of the body that are essentially cooperating with this killer. So you've got the assassin bug, and then you've got these other little things that are off to the side that are waiting for the assassination to happen so that they can swoop in. So in a sense, they're sort of like scavengers, I guess, but that level of specialization is really cool to me.
When you first got interested in bugs, was it these kind of things that first drew your attention, kind of the most bizarre aspect of it?
Yeah, I would say it was kind of the bizarre aspect of it, not so much the bizarre behavior, but the bizarre morphology. When you look at insects, again, they are really alien-like. When you watch movies, a lot of our inspiration for what aliens look like are insect-bound. And since there's so many species of insects, there's well over 1 million described species, and there's countless millions on top of that remain to be described. There's so much diversity of morphology there, and when you start looking at them, and that's what got me interested, was just like the many shapes, fashions, and forms. Every little bit of them can vary between species.
And one of the other things that they showed in the BBC video that was over there was the thing growing out of its head. But talk a little bit about how long that takes and whether the insect is alive or dead at the point.
Right. So in this particular case, what happens is that the fungus is growing inside of the ant, and then it will eventually alter the behavior so that it climbs up a leaf and locks onto a plant. And then the process of this weird fruiting body growing out the back of its head can take up to about 3 weeks. And is it alive during that time? At some point, no, okay? Because that's the whole reason why the parasite, in this case the fungus, alters the behavior of the ant to clamp its jaws onto the plant and dig in essentially to the plant, because if it died, then it would just fall, down. So at some point between that 1 and 3 week period, that's it for the ant.
Yeah, there are a lot of well-known films that use insects like them
and
tarantula. But could you mention a science fiction film where it's not overtly an insect, where you think it's taken something from the insect world?
Without a doubt, Aliens, or the whole Alien series is definitely grabbing from the insect world. This idea of instead of calling it a parasite, we call it a parasitoid, because a parasite, a tick's a parasite. You can get a tick, but you're not going to die. But in Aliens, and in the case with a lot of these different types of insects, what happens is that you're getting the injection of a larva inside of you. That larva develops and then bursts out and you die, just like, in the natural world, so is in Alien. I'm trying to think if there's some other... Well, actually, almost all of the zombie films, there is this element of the mindless horde, and that ants and termites and all sorts of the social insects kind of evoke this same sort of idea of a mindless horde, because their numbers are huge and they seem to not have any free will because they're all driven by this queen of some kind. That's a kind of reoccurring theme that in zombie movies and some other, the body snatchers as well would fall into that category.
So would you be inspired as a work-related thing to now play this game?
I definitely check it out. Mostly because what's interesting to me is that there is some really cool aspects of this relationship between this fungus and the ant in terms of how the fungus drives the behavior of these ants. And I would be interested to see, if the writers of this video game, how far did they take that? What are the behaviors that are adaptive for the fungus that it makes humans do? Do they climb to the top of buildings so that their spores can, go farther? Or they, what sorts of interesting kind of adaptations is the fungus forcing the humans to do that normally humans wouldn't do? Because that's the really cool thing, is that another organism is altering the behavior of you in this case.
So do you think this opens up some moonlighting opportunities for you?
That sounds great.
Getting some ideas.
Yeah, exactly. Call me. Yep. Yeah. Another cool insect story along the lines of, if I could choose any one to sell to a movie company or something like that, is that there are these wasps that infects spiders. So they lay eggs on the outside of the spiders, and the wasp is again just sucking the juice out of this spider very slowly, but the spider's still alive. And they're your classic kind of orb weaving spider with the very typical spider web, right? And when it gets to the point where it's ready to okay, the wasp larva is going to pupate and turn into an adult. Again, it does something, and it seems to be chemically based, that causes the spider to no longer create these typical spider webs, but instead it does, it creates a very strong set of guy lines, I guess, that in the middle of it will begin making the cocoon for the spider. So it creates this little webbing packet that then the larvae itself pupates within, and it doesn't use sticky web, because in spiders you have both sticky web and you have non-sticky web, and so it's very much again altering the behavior of this spider. And they've taken done things where they've taken the wasp off of the spider. and it will continue just making normal webs. But after a certain point, it does something to the spider that even if you take it off of it, it will still make that weird, little bed for the baby kind of thing, and definitely.
Look, he's crawling up my wall, black and hairy, very small. Now he's up above my head, hanging by a little thread. Oh, it's the spider.
I'm Beth Accomando, your resident cinema junkie. Thanks for listening to my podcast. Please go to iTunes to subscribe and give it a rating. The KPBS Cinema Junkie podcast recently launched, so I'd love to get some feedback. You can also follow me on Twitter @Cinebeth and like my Cinema Junkie Facebook page so you can mainline film 24/7 with me.
Where's he gone now? I can't see. Where is the spider? Where is the spider? Wrapped in a ball, doesn't seem to move at all. Perhaps he's dead, I'll just make sure. Pick this book up off the floor. Where is the spider? Where is the spider? A sticky end. Don't think he will ever mend. Never more will he crawl round. He's embedded in the ground. Where is the spider? Where is the spider?
KPBS On Demand is supported by Paint Care, offering households and businesses in California more than 800 leftover paint drop-off sites for recycling. Quantities of 100-plus gallons of paint may qualify for a large volume pickup. Learn more at paintcare.org.